This is week 7, so we're more than halfway through the term, and this is fuzzing week, so I am going to wear fuzzy socks to talk about these papers, at least for this recording, maybe not for our meeting tomorrow. They do make it hard to manipulate the papers, but maybe then I won't flip through the papers while I'm talking about them. Corny jokes aside, the notion of fuzzing has become quite important, and the idea here is that you generate inputs for the program randomly. And so we have two different papers here with fuzzing related topics, both from ICSE 2021. And I'm going to talk about the input algebras paper first. So this paper, the idea is to enable users, developers, whoever, to produce specialized grammars and use those grammars for fuzzing more easily. And so the idea is you have a grammar that exists already, and it turns out you want to put some constraints on the things that are produced by that grammar when you generate from that grammar. And so you modify the grammar by saying that you want to get inputs that have this property or that do not have this property. And this is important because sometimes you want to generate inputs that, for instance, get past a certain gate. And if it doesn't get past that certain gate, then it's just not going to do anything interesting. And so you want to generate inputs that are actually interesting. This is a new technique for doing that. It's something that you can do manually, so it doesn't actually add extra expressive power, but it does let you do things automatically. And so it's, of course, useful in computer science to enable people to do things automatically. They say, yeah, they have patterns and you can combine the patterns and then you get another grammar which then you can use as previously. Right, so that's the paper on how to generate new grammars for fuzzing which are better suited to what you want. And I have plenty of opinions about this paper, which we will talk about tomorrow. The other paper that I want to talk about is the fuzzing symbolic expressions paper. And in this paper, it's an application of fuzzing, really. And so there's a thing that exists already where you use currently a SMT solver, satisfiability modular theory solver, but SMT solvers are potentially expensive to run because in the worst case, they have to do this exponential search through the program space to find satisfiability or unsatisfiability of the formula. And so the idea here is they want to be able to run SMT solving more quickly. And so, well, we're not going to get the full guarantee of having an SMT solver, but maybe if there is a solution and it's near a solution that exists already, then we can use some heuristics. And they have quite a few heuristics. The heuristics are based on constants that you might find in your program. So it's not a general SMT solver. It's SMT solving technology that is customized to the specific context of concolic and hybrid fuzzing engines. And in those contexts, where again you often have these gates, you want to specialize your solution, your search for solutions to certain parts of the space. And so then if there's a solution that's close by where they're looking for it, then you'll find it potentially 50% faster than the SMT solver. Okay, so yeah, we have two papers, and we will talk about these papers and learn a bit about fuzzing. The first paper doesn't require too much background knowledge. I feel like the fuzzing symbolic expressions paper really depends on what we know about the application domain, and it is true that in this course we don't know as much about the application domain as we might otherwise, and so that makes it a bit more tricky to read this paper. Hopefully we'll have some papers, some examples in the paper presentation, which will make it easier to follow. I will say that the fuzzing symbolic expressions paper does have a number of examples, but these examples may be hard to follow. Like they kind of make sense, but they kind of don't make sense unless you really understand what's going on behind the scenes. Why are we doing this? All right, so we will talk about these papers very soon. See you soon.